corpse can be a habitat just like a forest or a fruit, and goes through stages of succession in a similar way. Understanding those stages can help us to determine the PMI or the post-mortem interval, even if the corpse is not fresh anymore. It can sometimes give us even more information, for example, whether the corpse was moved and whether it was continuously accessible for insects. There are also cases where insects can help us directly to find out the cause of death or to identify the person who is to blame. As soon as life is gone, under certain circumstances even before, our bodies are colonized by the very first corpse insects. Blowflies are often the first ones to smell a fresh corpse. The females prefer warm and moist places for their offspring. The first places colonized are body orifices like mouth and eyes, but also places that are covered by fabric. Most attractive are open wounds. If we find a relatively fresh corpse, we will find dense carpets made of maggots in those characteristic regions. Close attention to those regions can help us to find out whether we have a settlement expected for the current position of the corpse. The size of the larvae, or whether they are already pupated, can be used to estimate the minimum time the insects had to colonize the body. A weird case of insurance fraud could be resolved because of blowflies. A woman was reported missing by her husband. A few days later, he called the life insurance of his wife and wanted the money. He got the answer that his wife did not count as dead just because she disappeared a few days ago. A week later, he called the police because he found his wife's head that was severed post-mortem. The police could only find blowfly larvae at the cutting wound, neither at her eyes nor in her mouth, meaning that the wound was the best place to lay eggs when the body was first accessible to insects. The corpse was inaccessible when it was intact. The age of the larvae showed that blowflies first had access to the corpse when the man called the life insurance. This made it likely that the man killed his wife and wanted only the head to be found to get the insurance money without letting the police see the deadly injuries on her torso. But how did they find out the age of the blowfly larvae? First, we need to measure our larva and use a diagram like this one to find the right isoline for the length of our larva. What else do we need? It is important to calculate the mean temperature based on weather data and measurements made with the data logger at the location where the body was found. With this temperature, we can conclude from the diagram how much time the larva needed to grow to its current size and how much time it spent as an egg. Of course, those isolines differ for different blowfly species. This table is for Lucilia sericata, maybe the most famous insect used for forensics. But we have heaps of larvae on this corpse. Do we have to measure every single one of them? No, luckily not. Usually, no one cares about the young ones. It is important to find the very oldest larva. Since flies like Lucilia need daylight, those oldest maggots might be very seldom on people that died in the early evening, but those carry the crucial information. Older larvae tend to leave the corpse to find a good place for pupating. Therefore, they might even leave the crime scene. This is why corpses on flats are often found. The larvae appear below the door. If the oldest individuals are already pupated, we can, for example, wait for them to finalize their development. If we find empty pupae, we need to say that the fly just emerged. In each case, insects will only tell us a minimal postmortem interval, not the actual time that passed since the person died. But even if we only know that the corpse lied there since at least 14 days, while it actually died 20 days ago, we can already say that Miss Meyer, who came to the town 5 days ago and acted suspiciously, is not the killer. This was relatively uncomplicated, but it is about to get more difficult, since we cannot always rely on blowfly larvae. As time passes, the environmental conditions in a body change as well, leading to changing species compositions. In the beginning, we have mainly blowflies, and also flash flies. Bacteria within the corpse start the process of putrefaction, leading to a bloated appearance of the body. The internal temperature of the body rises, and decay fluids influence the environmental conditions surrounding the body. When the actions of maggots and other decomposers lead to a breaking of the skin and an escape of the gases, decay begins. Now coleopterans join the feast in increasing numbers. In the end, most of the flesh is removed, and the blowflies leave. When just skin, cartilage and bone are left, coleopterans are the main inhabitants of the body, mainly Dermestidae. Finally, the body is reduced to hair and bone. But not all bodies decay the same. A body can stay around for longer, and the following stages can interrupt petrification. If the corpse dries at some point or directly, which inhibits the decay caused by bacteria, it mummifies. Saponification of body lipid happens to corpses in a wet and anaerobic environment, for example, wet graves. This wax-like protection preserves the body and gives it a clump-like appearance. The duration and path of remineralization depends on environmental factors like aridity and temperature. A corpse in a warm summer forest can be skeletized within weeks, while the corpse of George Mallory, who died climbing the Mount Everest in 1924, is still in a relatively good shape up there. During these changes that happen in a body after death, various insects find their niche on our mortal remains. Cheese skipper flies, that got their name from the jumping behavior they show when they sense danger, like to join the feast when the tissue is already a little bit more liquid and gains a mush-like texture, and colonize not the whole body but only areas that are attractive to them, and also often bodies of obese people, which shows that decay is individual and different for every person. Dermestidae show up on later stages of decomposition and only if the body is drying. They feast on dried skin and hair. As opposed to blowflies, we won't be able to get an exact time with these, but we can still get some information about the minimum postmortem interval. Even if this is 40 days when the person actually died over 70 days ago. However, since beetles of different families are not as reliable for PMI analysis, but can be used to give information about a longer time interval, often the whole community of beetles is analyzed to find a stage of succession. Other examples for beetles on corpses are Trogidae, that also feast on dried skin and hair. They can stay for a year on mummified corpses. Sylphidae that are large can even deal with extremely mummified skin. Hysteridae start to get more prominent during the stage of decay. Many Hysteridae hunt blowfly larvae. Therefore, they arrive at the time where we already have blowfly larvae and lay their own eggs, offering another way to calculate the PMI based on both animals. But beetles are not always helpful. Sometimes they can make an accident look like a crime. Beetles of the genus Necrophorus can create caves in corpses for their offspring. Those can later appear like shooting wounds. These apparent murder cases can be resolved quickly, but still those cases have to be started as murder cases. There are a few things that are important to consider when dealing with a body indoors. This body was found in his flat after he didn't pay his rent for several months. The body is in a mummified to skeletal stage, but how is it possible that no one noticed? While there are many people that die unnoticed, neighbors can seldomly ignore maggots, squirming below the door to find a place to pupate. So, have blowflies never been there? First of all, whenever a body is not out in the open, whether it's in a car, a flat, a suitcase, or a towel, the most important thing to find out is how accessible it is for insects. We might be able to say when, statistically, insects would find a way to reach the body. This room was apparently accessible through the gap below the door, and there were very few dead blowflies inside, so accessibility was not the issue. The man did still have his hair, while fly larvae usually lead to the dislocation of the hair. The flat was also warm enough, even during winter. But why couldn't they access the body? Only Domestidae were found. Those usually feast on mummified corpses. The body apparently mummified too quickly for blowflies to find a suitable habitat in it. Some old sofas can lead to a relatively quick mummification, since they soak up the liquid and let the body dry, but that was not the case here. Instead, there was a fan heater, close to the face of the man, that he apparently put close to his deathbed to have it nicer. After he died, the heater continued to run until the energy was shut down, months later, drying the corpse and especially his face effectively. The corpse remained unnoticed for almost a year. How and where a body is stored between the time of death and its discovery influences which insects we can find by the time the body is discovered. It is crucial to consider the local conditions of the decaying process. Many corpse insects are typical for certain habitats, like rural areas or forests. Even in the same habitat, we can get different expositions to sunlight, letting the corpse dry at a different pace. If the corpse is buried, it gets inaccessible for blowflies, while flies of the family Phoridae can dig their way to the corpse. And if we get into aquatic habitats, it gets really interesting, since we don't know much about insects on corpses in the water. But there are cases where water-living insects can indeed help us to solve a case. In 1952, a corpse was found in a river. On one of his red socks, there was the case of a Trichoptera larva. This Trichoptera larva found the socks of the corpse and decided that they are case material. The speed of case creation of Trichoptera larvae and the amount of case that included the red sock material resulted in a minimum of 1 week the corpse had to lay in the water, disproving a former theory that included a water laying time of 2 days, helping to find the killer eventually. Also, seasonality plays its part. If the person died between late autumn and early spring, only few insects are active. Temperatures below 10 degrees often hinder them from laying eggs. Individual differences in that regard often lead to few maggots in the beginning. The corpse has the possibility to dry out and mummify in the meantime, making it inaccessible to blowflies. So, an old corpse without any blowfly remains might have died in winter. The species richness of the remains of the first colonizers can also help to determine the season the person died. There are some species that are active in the cold, and some break their diapause when it's warmer in between, making it possible to find out whether someone died before a short warm period during winter. The fly Photophormia pteranova is active earlier in the year, meaning that a corpse that was directly colonized by maggots, but only of that species, have to have died during the colder month or in a cooler environment. How can we work with insects if their composition depends so heavily on environmental conditions? Only a lot of experiments, often done with pig corpses, but in certain countries also with human corpses, can help us to understand the dynamics of those insect communities. Sometimes it is necessary to perform experiments just for one case. Sometimes a body is found at a place where it didn't die. Insects can help to find out whether that was the case and where the person met their fate. Sometimes we can find insects that are not specialized on corpses and that do not occur everywhere and are not able to disperse quickly. One example are Staphylidae. Those beetles are often quite specialized in their habitat, signalizing the transportation of the corpse if they don't occur in the environment. If a corpse was at a place for a time span and removed just a few hours before this temporary storing place was found, it might be possible to find their DNA in fly feces at the crime scene or in maggots' intestines. Poison, drugs, etc. can be taken up by insects and detected in them even if the body itself is already too decayed for that. Even after years, empty old pupae of, for example, beetles can be analyzed. But a negative test result does not mean that there was no provable poison involved. Dermestidae are also useful here. Anthropogenic effects that influence our environment can also affect forensics. An increasing temperature because of climate change will first of all also increase the activity of insects. Very high temperatures can affect the survival of common blowflies, since it's simply too hot to survive or to lay viable eggs. Temperatures above 40 degrees impact, for example, Formia regina and Lucilia sericata. They cease to lay eggs at some point and have a lower adult survival. No individual survives temperatures above 44 degrees. Hot summers will make forensic entomology difficult. Also, invasive insects can challenge forensic entomologists. One example is Chrysomia albiceps. These changes make more research necessary. Insects can help us in various ways to solve mysteries involving corpses. Further research in the fascinating field of forensic entomology is needed to receive more information from those little helpers, and also to adapt to recent changes in our environment.